Imagine you're in a rocket that left Earth's atmosphere and stopped halfway to Mars. You're getting out of the cabin into outer space to enjoy the view. You take off your spacesuit helmet, take a deep breath, and observe a moss-covered asteroid fly past. But suddenly, you hear a strange sound. No need to panic, it was just a supernova exploding in a nearby galaxy or space yaks fighting for territory on the asteroid. I feel like that's what space would look like if air appeared in it. Or not. The consequences might be completely different. So, will we be able to survive in a world with air in space? To fill, for example, the solar system, we'll need a lot of air. At the same time, our system will become 6 billion times heavier than the Sun, and that's even more than the mass of Sagittarius A*, the supermassive black hole at the center of the galaxy. This will definitely take its toll on us. But let's take a moment to put aside the friction force, gravity, and other laws of physics and consider the ideal version. Earth's atmosphere is heterogeneous. It has a series of layers: the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. And the farther away you get from Earth, the thinner the air becomes. If we fill the solar system with a mixture of gases, they won't fill the space uniformly either. The nitrogen and oxygen molecules that make up the air will be distributed according to gravity. For example, near Jupiter, the air layers will be very dense. Due to this, the pressure near the gas giant's surface will be the same as at the bottom of the Mariana Trench, and that's almost 1,000 times more than on Earth's surface. But in addition to such gravity wells, space will also have zones of rarefied air and low pressure due to the presence of gas through which sound waves can travel. Both on Earth and in space, you'll constantly hear this foreign hum that our Sun makes. With the emergence of air in space, the solar wind would become an all-too-familiar background noise. But unlike sound, the Sun's heat will no longer spread in the same way as in a vacuum. Our solar system will become darker and cooler. Now the temperature at the level of Earth's orbit reaches 4 degrees Celsius, but with the presence of air, it'll drop below zero. But even despite this, there will be enough heat, light, and oxygen in space to sustain life. With the emergence of air in space, some terrestrial species will be able to expand their habitat. For instance, Ruppel's vulture on Earth can fly at an altitude of 11 kilometers. The vulture's wingspan is over 2.5 meters. It catches the air currents with its wings and rises into the sky. If air appears in space, nothing will prevent the vulture from flying, for example, to the Moon or even Venus. But the bird won't be able to overcome the rarefied air zones since there's simply nothing for the wings to push off from. However, some insects can feel comfortable in these zones, like the Himalayan jumping spider. This spider can live in the mountains at an altitude of almost 7,000 meters. It feeds only on insects that are blown up to its altitudes, and since the wind will blow not only on Earth but throughout the solar system, the Himalayan jumping spider will certainly not remain without food. Even without the advent of air, there will be enough extreme places in the solar system where life is impossible. Well, almost impossible. Somewhere near Neptune's orbit, in the rarefied air zone where the temperature approaches absolute zero, tardigrades feel comfortable. These microscopic low-speed invertebrates can withstand extreme temperatures ranging from -270 to +150 degrees Celsius. In addition, they can live without water for decades. A study conducted in 2007 showed that tardigrades can survive even in the vacuum of space. But not only microorganisms like extreme conditions. In Jupiter's radiation belts, where radioactive radiation disables spacecraft devices, you can find braconid wasps just living their lives. These insects can withstand a radiation dose 200 times greater than a human, up to 1,800 Gray. But to survive near Jupiter's surface, you need other abilities. There, the planet's immense gravity will create a pressure of 1,072 atmospheres. For comparison, the pressure on the surface of our planet is 1 atmosphere. But it doesn't prevent the emergence of life. Abyssobrochula galathei is the deepest living fish known. It can even live at the bottom of the Mariana Trench at a depth of 11,000 meters. However, Abyssobrochula galathei lives only underwater. But it's entirely possible that a similar species could appear on Jupiter's surface under the influence of radiation. And these processes would take place not only on Jupiter. With the emergence of air, new species would evolve in space, for example, on asteroids. If there's atmosphere in space, rock asteroids could become covered with moss. This species is unpretentious and can grow even on Everest at an altitude of almost 6,500 meters. Such green asteroids could become home to small rodents such as the asteroid mole rat. Just like the naked mole rat from Earth, this rodent can live without oxygen for 30 minutes, so the asteroid mole rat will manage to survive if it gets into the rarefied air zone. Moreover, this animal doesn't feel pain or cold and never comes to the surface. That way, it'll be able to protect itself from solar radiation and survive temperature fluctuations. And the double tail will allow rodents to better navigate in space in a low-gravity environment. But not only small species will be able to survive on the asteroid. The herbivorous space yak can reach the same size as the wild yak on Earth, up to 2 meters in height, and their weight ranges from 500 to almost 1,500 kilograms. The lungs and hearts of these animals reach enormous sizes. This allows terrestrial yaks to survive in the rarefied mountain air at an altitude of 5 kilometers. This will also give an advantage to space yaks because the atmosphere on asteroids is not as dense as on Earth, and an additional pair of legs will help keep them stable even in low gravity. And since animals could survive in space, comfortable conditions for humans could also develop there. Now you don't need rockets to fly into space. You just have to get on an ordinary plane, and within just a few hours, it could get you into Earth's orbit. There, you'll be able to get out of the cabin into open space and take off your spacesuit helmet. The air density in orbit will be suitable for breathing. However, it'll be possible to breathe deeply not everywhere in the solar system. Somewhere rarefied air or critically low temperature will prevent you from doing it, and somewhere like near Jupiter, radiation will interfere. But in Earth's orbit, you're entirely safe and can enjoy the view. Truth be told, a beautiful picture would be ruined if we go back to the laws of physics. Space is not as empty as it may seem. The thing is that it already contains air. It's just that there's very little of it, and it's not suitable for breathing. The average density of the universe is 0.3 of a proton per cubic meter. In the solar system, the space density is much higher, it reaches 9 protons per cubic centimeter. And the inner orbit. The matter density is 10 quadrillion times higher, but if we change these values even just a little, the changes will be catastrophic. For example, let's pump up the solar system with air to the density of a molecular cloud. Then, instead of 9 protons, 1 cubic centimeter would contain from 100 to 1,000 particles. The first thing we're gonna see is Jupiter turning into a star. The planet's powerful gravity will attract enough matter to turn into a gas giant and into a full-fledged second sun. And that's bad news for us. The thing is that Jupiter is almost 3 times closer to Earth than the Sun. This means that our planet will receive additional heat from a new star. The temperature on Earth could rise to Mercury's temperature, which is 650 degrees Celsius. But we still have a chance of survival. You see, if the density in the solar system increases, Uranus and Neptune will be able to form a full-fledged atmosphere. And due to the burning Jupiter, the temperatures on these planets will no longer be so extremely cold. Fortunately, the process of transforming the gas giant into a star will take many years, and humankind will have time to prepare and relocate to Neptune. But what if we increase the density not only of the solar system but of the entire galaxy? The first thing we'd notice is that the Milky Way would become brighter. The point is that the stars will have extra fuel and gas giants like our Jupiter can become new suns. But that's not all. Our galaxy will become much heavier. The Milky Way will start gradually consuming its neighbors. The large and small Magellanic Clouds will be the first to suffer. After them, the Milky Way will absorb the Triangulum Galaxy and finally Andromeda. However, we're unlikely to be affected by the consequences of these mergers, but watching the starry sky will become more exciting. If we increase the amount of density in our galaxy by only 10 times, it'll devour all its neighbors, and humanity will have to move up to Neptune to survive. But what will happen if the density in space is the same as on Earth? For the air density in the solar system to become the same as on Earth, it has to be increased 10 quadrillion times. And if we just do that instantly, Earth will be torn apart. The thing is that we revolve around the Sun at a speed of 108,000 kilometers per hour. The friction force will destroy our planet in a split second. But if space is filled with air gradually, it will initially look like the Sun has gone out. Its light and heat will hardly penetrate the denser layers. But people won't have time to freeze, and not just because Jupiter will turn into a star. After all, the orbits of all the planets will shift increasingly closer to the Sun. To avoid falling on its surface, we'll have to increase the orbital speed by 1.5 times. But even if we manage to figure out how to boost Earth's orbital speed, humanity will have another surprise: meteorites. Since the solar system's density and mass will increase, its gravity will increase too. And then asteroids from the Kuiper Belt and the Oort cloud will hurtle towards the Sun and the planets of our system. Earth will face meteor showers of such force that a new ice age may begin. In addition, the impact of particularly large meteorites can trigger the displacement of tectonic plates and the formation of a new continent. And people aren't going to like that. Earthquakes, tsunamis, and volcanic eruptions will become habitual to us. In addition, the Moon will begin to orbit increasingly closer to Earth until it falls on its surface. But we still have a chance. I mean, the solar system's gravity will attract not only meteorites, we can also capture new planets. And who knows, maybe humanity can build a new home on one of them. From there, we'll be able to observe an incredible phenomenon on the northern lights of the heliosphere. Charged particles of the solar wind will collide with nitrogen and oxygen molecules. Because of that, new charged particles will appear, forming a red-green glow. But over time, the air-filled solar system will become so heavy that it'll descend from its orbit. Instead of orbiting the black hole at the center of our galaxy, we'll begin to approach it. And after a while, Sagittarius A* will tear us apart and consume us. If air emerges in space, humanity will have no chance of survival. But what will happen to the universe if we fill not just our galaxy but the whole of space with air? A colossal amount of matter will be added to it, and this matter, air, has mass and gravity. Under the influence of these forces, the air would compress and collapse, forming huge red-hot clumps of matter, new types of stars. Over time, these stars would gather into galaxies, and planets would form around them. And from air, a new universe would come into existence.